Hello. That introduction music was unplanned. It was improvised on the spot. My talk isn't Star Wars themed, although it might seem like it from the music and the opening slide. Can you all hear me? Does it sound good? All good? At the back? Excellent, thank you. This is me. I work at Twitter. I work on a product that some of you might use called TweetDeck. We have kind of about 1.5 million users who are particularly good tweeters. They get kind of disproportionately high engagement, although I don't like the term engagement too much. And it's most likely the accounts you follow use TweetDeck. I have some Twitter t-shirts and stickers, so if you want to come, I've only got a few t-shirts, so grab me maybe in the discussion track if you want to get one of those. And this is the hashtag to use if you have any questions about this talk. I'm going to run through a lot of stuff very fast, and I'm hoping that we can pull out the really interesting stuff in the discussion track. The other thing to say about this talk is that it's very bleeding edge, and quite likely that some of these slides will be wrong, possibly even right now, because the work on what I'm about to talk about is happening on GitHub, and things are changing day to day. But what I'd like to do is get everyone excited and interested in this topic and get people thinking about the problem and involved in working on ServiceWorker and making the web good in an offline situation. So firstly, why do we care about offline? Well, we have to accept some truths about the way things are today. Connectivity isn't ubiquitous, although we often build sites on the assumption that it is. Most of the places, or lots of the places where you spend time, you have no connectivity. On a train, quite often, in a car, when you're walking around, and in the tube, which is a particular sticker for me. And also in places that we often forget about, like developing nations, there is not necessarily the same kind of 3G connectivity that we have in Europe, in the States, in those places. And we really should be thinking about the web as a viable platform in those places. So that's why I think this is a really important problem to address. Where are we now is quite an important question to ask, so we can build on something. Right now, if we're wanting to build offline sites, there are a few options, but really we're talking app cache or native. And I hope my GIF is playing. Yes, cool. We have to be honest, native is an option. If you have to build something that requires offline capabilities, native is something you have to look at. And as people who build things on the web, for the web, we have to say, we're not getting this right yet, and look at what we can do better. So who's doing this kind of thing, doing it well and doing it badly? Well, the mobile lanyard site is one of the sites that uses app cache, and I believe the Financial Times mobile site does the same thing. This website spawned the app cache douchebag article, which I'm sure some of you will have read, which is a really good article, which also spawned the ServiceWorker stuff, which is the main content of what I'm going to talk about. There's another site called DevDocs, which I think is really promising, and I really like the idea of, but unfortunately the execution is somewhat lacking. They use app cache to cache the shell of the app, so all the assets for the for the menu bar at the top and the sidebar and all this kind of stuff, all that CSS is all cached using app cache. And they claim to work offline, and if you read the help documentation, it says, yeah, all this stuff is available online. But what actually happens if you do try to use some documentation offline is you get this. Now, it seems to me that they've kind of missed the point of offline there. What they let you do is search the documentation and don't let you view it. So you go to DevDocs and it loads. That's a really big plus. And then you start typing in something that you want to find out about. And it's there, and you get really excited, and you hit enter, and then you get this page. And that was really quite annoying and cut me deep. Looking at local storage, we can see what they're actually doing here. They are caching, as I said, all the bits you can search, which would be the titles of the page and some descriptions. But they're not caching the content. And this kind of hints at one of the problems that we need to address when talking about offline on the web. Suitability and space constraint. Local storage in a lot of places, particularly on mobile, will have quite a significant space constraint. And it's really not suited to the use cases we're talking about. And that forces developers to do things like this. There's another reframing of the problem that we have to do, which is to do with thinking about online as the problem, not offline. Realistically, there's actually no way to know whether you're online or not. Particularly thinking about airport, hotel, and train Wi-Fis. Often they will, and coffee shops are another good example, they'll often let you connect to the network without typing anything in, and then they'll catch you and say you have to give us all your information and the first names of all your children and sign them away to us. And then you're not actually online, even though if you made a request, you might actually get a response. So a way to detect the network by just pinging and seeing if you get a success response doesn't work. So really, online is very hard to define, and that's the problem. If you follow that logically forward, you come to this idea of offline first. If we can't know that we're offline, we should take the stance that we are offline and enhance from there. So there's a kind of idea that we could center around, which would be to treat the network as a potentially unavailable resource. So in exactly the same way as we say, if you're progressively enhancing a site, does this browser have a feature or doesn't it? We need to start thinking about the network as a progressively enhanced feature. Once you've delivered your code and some content to the browser, treat the network as optional from there on and do everything as if you're offline, and then speculatively do online things, hoping that they work. But that has a few further implications. We're not very good at this stuff right now on the web, and we really need to be better at it. There's some things we have to start learning how to do really well, things like synchronization and batching and doing things later. Just being happy to just say, you know what, I'm going to forget about whether that works. And that also has a ton of user experience implications. So if this is going to happen and we're going to do this well, we need input from the imposter community, the design community as well. So the main content of this talk is the service worker, which is a new piece of technology. There's some buzzwords up on the screen there, but it kind of summarizes it quite nicely. An event-driven, so it's going to listen for and respond to events from other places. That might be the documents, might be things like push APIs. Web worker, so it's JavaScript running in the background, not associated with a particular document. It's able to generate responses to requests made from the page. So a service worker will be associated with a document, and that document will make requests. So it will ask for images, it will ask for CSS, it will ask for scripts, and the service worker is able to intercept those requests and respond to them, or allow them to go to the network, or cache the response that gets back from the network, and or generate a failure response if all of that fails. Conceptually, this can be kind of hard to grasp, so I've put together some little diagrams. Hopefully, you kind of get that this is how browsers work. If you're well, I won't assume that you know it, but if you didn't know, this is how browsers work. The previous technology we had for offline was app cache, and I don't know if anyone's played with app cache, but it had some pretty severe limitations. This is kind of a summary of how app cache and the page and browsers interact. The page doesn't really have any access directly to the app cache. It's done, the changes to the app cache are done declaratively, and so it's up to the browser how it interacts. And unfortunately, the API that app cache had left some issues that meant you could get into unrecoverable error states, and that's not ideal. So the browser has programmatic access to the app cache, but we, as authors, don't. So Service Worker sits in between your page and the browser and its network stack, and therefore the network. And this allows us to do some really interesting things. So as I said, it can intercept and modify and respond to requests from the page. And that includes cross-origin requests. So if you're requesting something from CDN, if you're requesting something from, I don't know, some other website, like a library's hosted elsewhere or CSS hosted elsewhere, your service worker can intercept those. As long as it's from the same document, so iframes, you won't be able to intercept if they're on a different domain, but things like CSS and scripts, even if the cross-origin, are interceptable. And the other thing Service Worker has access to is a new API, which is the Cache API. So this is a promise-based set of APIs. if you haven't played with promises, there's sort of some promise-based stuff later on. The really important thing is that it's programmatic access. You can read the code and figure out exactly what's going to happen to each cache, and it gives you a ton more power than app cache ever did. And the other thing, kind of conceptually, is that it's one-to-many. So kind of like a background pages with an extension, ServiceWorker is one-to-many. So you will have one ServiceWorker that will be associated with all the documents that your user has open. So if they have your site open in multiple tabs, all those tabs will talk to the same ServiceWorker. One way to think about how one way that things are going to change is we're going to have to start thinking about the things we build as a shell plus some content, and that produces the app or whatever word you want to use for the thing you build. There's this pattern repeats over and over again. Tweets in TweetDeck, articles on a news website, your emails, posts on a blog. There's fundamentally some framework, some shell into which the content of your site is poured. And the idea that we're going to have to start thinking with, and the concept is cache the shell and cache a subset of the content that your user would like. So for example, a Netflix app would allow you to choose which videos you wanted to cache offline. So you have a subset of all the available videos cached on the device. This is not kind of foreign territory, but it's often not how we're thinking about building things at the moment. So let's have a look at some example code for how to do a service worker. So this is from a document, from a page. This is would be just some regular JavaScript, and you're saying this page is registering and associated with a service worker. So the worker just has a URL. It's just a JavaScript file in the same way as you might spawn a worker. You can also say, I only want the service worker to deal with a subset of the available URLs. So this worker is only associated with my blog. That's going to be really useful for teams who are working across one domain, like twitter.com, where you might want multiple workers for different parts of the site. And what happens when a request is made from the page is that the browser will perform a matching on the URL and say, which worker should I distribute this request to? And it's spec'd up on how that works, and I won't go into it now, but if people are interested, we can talk about it on that, using that hashtag. I mentioned the caching API. So this is how you create a cache and how you populate it. Now this API is promise-based, so when you add to the cache, it will convert those URLs into a request. The request will get made, and then you can wait using a promise on the result of that caching. So you know that all those things have been cached, because the promise will either, I can't remember what the exact terminology is, but will either succeed or it will fail. And it will fail if any of the things that are going into your cache fail, which will be really useful for saying, this is the minimum requirements I have for my app. If you can't cache these, I need to know about it because I need to tell the user, or I need to refresh their page, or I need to act on that. And that's one thing you can't do with app cache. And then to make these caches persist across worker restarts, and that's an important aspect of Service Worker, it will, like a server in Node, it can be killed and started at any time. So you can't be holding things in memory the whole time. You have to work in a way where you do some work and save it, and then on the assumption that your worker is going to be killed, and then later on you can bring it back up. So what's happening here on the bottom line is we have a list of caches, and we're saying, this cache I've just created, please persist it and use the name app v1 to save it. The important thing there is the v1, which means that cache is versioned. So versioning is an important part of the whole service worker spec, and because one of the best ways of being able to manage your worker and your code through time is by versioning it, and so it's tied very well to into the service worker spec. We want people to be creating new caches, versioning them, and then having those caches kind of migrated between workers, and as your code changes and as your app changes. So this is how you might intercept a request coming from the page and respond from your cache. So it's just an event listener. It receives an event, And then there's this new respond with method, which accepts a promise or a response. So what I'm saying here is go and look in the cache for a request, well, actually for a response that looks like this request. So I could have cached a request for my CSS, and then the next time that the page requests that CSS, I look in the cache using this request for the CSS. It matches, finds the same URL, the same kind of, it matches on different kinds of headers, and then it will return the response that was cached. And then we pass that back to respond with, and that will get sent back to the page. There's lots of failure cases here. For example, if the cache, if there was a cache miss, and we can respond to that too, and we can talk about what that looks like in the discussion track. So as I said, it matches based on the request. So a cache is a map, if you like, from request to response. And so a lot of this ServiceWorker stuff relies on the ES6 stuff that's coming to browser. So promises is a big part of that, and maps, being able to map an object, being able to use an object as a key to a map will be really important for ServiceWorker. There's a couple of other events that are associated with service workers, and they are kind of grouped as lifecycle events. So there's a lifecycle for a worker which kind of is boiled down to registration, where a page says, I'm associated with this worker. Install, where the worker can do some work like build up its caches and get ready to serve responses. And then activation, which means that the page's requests are now going to be routed through the service worker. Kind of implicit in that is that when a page first loads, it won't, even if it registers a worker, it won't get access to that worker, or rather the worker won't immediately start intercepting requests, but you are able to force the request to start coming through the worker. So there's these lifecycle events that you can respond to, and there'll be places to do different things like upgrade your previous caches. So you probably do that in onActivate. You'd say, I'm coming online, the previous cache was this one, the data format has changed, do some upgrades, right now I'm ready to serve requests. So where are we with Service Worker? It's not in browsers right now, although last night it got to a W3C first draft. The spec development is all happening on GitHub, which is much nicer than on any of the mailing lists. It's really user-friendly. Everyone there is very open and happy to answer questions. So that's the URL if you'd like to find out more about it. Essentially, the people who are working on it right now are a few people from Google, and Mozilla are quite heavily involved, also Samsung. And it would be really great to have more people involved. I said it's not in browsers, but Chrome, well, Google are hoping to have it in Chrome this year. That's kind of what I've heard most recently. It's being put into Gecko 2, and I don't quite, it's not very clear from the bug where exactly they are in implementation, but it is definitely happening. The people who work on WebKit have said they're interested in working on it. Microsoft have remained silent on it, and Apple, in terms of, haven't actually expressed an interest. And that's important because it being in WebKit doesn't necessarily mean it will make it to mobile Safari, and that might be significant. But I mentioned earlier developing nations, and it will be important that it ends up in Android, because Android is really the strong platform in those places. And if we can get it in the browsers in Android, then we'll be in a really good position to have offline working really well in those places. And it kind of reminds me of this, I don't know, kind of skit about how IE is dragging behind again, but this time it's IE and Safari. Just kind of going service workers, but in 2 years' time. My involvement was to build a kind of polyfill. It was a JavaScript-only implementation of Service Worker that used Node as a proxy. So you pointed your Chrome instance at the proxy server, and it acted like how the service worker is going to work in the browser. That's also on GitHub, but it's getting slightly out of date because the spec and the implementations in browsers are now moving faster than confident I can, because I'm not paid to work on this. Just kind of wrapping up now, the future of this stuff is really interesting, and this is already the future, so we're talking about the future here. There are APIs that are being worked on that will use ServiceWorker. So background sync is a major one, and the push API, so we're going to be able to push to service workers. There's a possibility for building a responsive image solution with service workers. There's the manifest APIs which are coming, which may, if not merge, be heavily integrated with service workers. And I think there's a distinct possibility that our frameworks will start generating service workers for us. So my message here is, it's your turn. Please get involved with the spec. Please get interested in service workers. Come talk to me afterwards if you're interested in it. Try this stuff out, prototype code, explore the UX implications, and really kind of push it to where it breaks, and then together we can have a really great offline web solution. So thank you very much, and ping me with questions on the hashtag. Thanks.